My name is Hannah Daly. I'm a researcher here at the UCL-Energy Institute. I'd like to welcome you all. I'm very happy to introduce John Barrett here from the University of Leeds. So John has been a chair in sustainability research at the Sustainability Research Institute in the University of Leeds for the past 3 years. His research interests include sustainable consumption and production modelling, carbon accounting, and exploring the transition to a low-carbon society. The models he has developed as part of his research are now used by numerous government departments to understand the consumed emissions in the UK, as well as the emissions embodied in trade. John works as an advisor to DEFRA and was commissioned by DEFRA to lead an understanding of the carbon footprint of trade. John is also a lead author of for the IPCC 5th Assessment Working Group 3. So I am instructed to point out the fire escapes too. This is to go out the door before you came in, and down the stairs through the front door. There's also a fire exit if you go out this door to your left, and through the student room and down the stairs. So the event will be an hour in total. In the first 45 minutes, John will speak, and please hold any questions until the end. And then we'll have 15 minutes for conversation. Please join us afterwards in the kitchen next door for some drinks and niddles. That will be until 7:30. If anybody here who's not a member of UCL-Energy Institute will need to find somebody with a card to let you out after 7 o'clock. So just be aware that you need somebody to let you out after 7 p.m. And then there are some UCL volunteers in the back who can advise you on that. So without further ado, John Barrett.
Great, thank you very much. I'll just say I managed to get food poisoning yesterday, so I'm on a diet of crackers and water. So I'm feeling quite fragile. So please be gentle with me when it comes to questions. And if I sit down, it's just because or if I rush out of the room, it's in a worse situation. But I think I'm over the worst of it. Great. So. In terms of what to talk to you about, when I was invited, I suppose being the Energy Institute, I thought I should talk about energy, but then I actually thought that I've always felt that climate policy potentially is focused purely too much on energy and not enough on understanding how the economy functions and whether that supports an increasing reliance on carbon space, on emissions, or whether the whole economy can move towards a situation where a low carbon future is a possibility. So I'm going to go through a few sort of what I see as logical steps to try and appreciate why I think we need to extend our idea of climate policy beyond that of understanding what to do with the energy system to one where we start to question our consumption and start to look to alternative ways by which we can deliver quality of life, equity and other potential positive outcomes for society, but by doing that with consuming less, or at least consuming differently. To start with, I just want to very quickly revisit what we mean and what we're trying to achieve in terms of a low carbon future. I'm always slightly dismayed when we constantly see 80% as the magic number for the UK, and if we achieve that, then we will limit global emissions and everything will be fine. When that 80% is a really value-loaded assumption made by the UK government. The 80% reduction in UK emissions from 1990 to 2050 is based on the probability of achieving a 2%, avoiding a 2% increase of about 50%. So it's quite a risky assumption to start with. It also assumes that the world's emissions should be equal by 2050. So therefore, any developed country with higher than average per capita emissions have a greater right to the carbon space up to 2050 than developing countries. So in essence, there's some key sort of equality and equity issues associated with this target. So if we take some of the IPCC's recent projections from Working Group 1, this is the global trajectory that we would need to be on for a 2-degree future. And if we were to actually distribute that proportionally, the remaining carbon space on a per capita basis, then the UK reduction wouldn't be 80%, it would be 97%. And that's also with a slightly higher probability of achieving the outcome. I suppose, what probability do you pick? Well, 2 degrees in itself is not a scientific measure. It's something which people felt was feasible to sign up to. Clearly it wasn't feasible, but if we were to achieve it, we'd be looking more at a 97% reduction over that time period. So if we compared this with what the Committee on Climate Change suggests for territorial emissions in the UK, then this here is the difference between them. So this is the additional carbon space which we need to account for. And obviously the fourth budget goes up to 2027. So therefore we would be looking more at having a 67% reduction over that time period. Now why do I think this is important? I think this is important because if we're talking about the wrong scale of reduction, we're not really talking about the kind of policy package and the intervention which we'd need to make to change the system at the speed that it needs to be done. Once we start projecting everything to 2050, 2100, we start to get the idea that it's okay if we have these slow, incremental changes year on year to bring about the change. So we're quite happy with 1–2% a year. We'd be very happy with 3% a year. But of course, this relates to something completely different if we were to think about an equitable distribution of the remaining carbon space. There is also the added situation that, of course, this is calculated from a territorial perspective. If the emissions occur inside the UK, they are the responsibility of the UK. However, this is becoming increasingly outdated when we think of the globalised economy that we live in. It's very difficult now to sit there and draw this artificial boundary around a country and say you are responsible for that and you're not responsible for any emissions which occur as a result of the consumption of that country. So we have a contract with UK government to provide the headline indicator to complement their current way of accounting for emissions from a territorial perspective, which I would say is the recognised way of reporting emissions by the UN. So it's not as if it's a UK decision as such. But the UK is the only country globally to actually have a headline indicator to also report its emissions associated with consumption. And this is developed with our multi-regional input-output model. I'm not going to talk so much about the model details. You can ask questions about the model at the end if you like. But in essence, it's a global trade model that understands the flow of money through sectors and through countries. It's a very large data system. And where we found production emissions have gone down from here, this happens to be 95 to 2011, we've seen that consumption-based emissions before the recession had continued to climb, and at the recession absolutely plummeted. And they plummeted at a greater rate than actually the reduction in GDP over the recession. And that was partly because the imports from China dropped by 67% from the year before in that year. And as you all will know, I'm sure, that China is very carbon intensive in its production. And so therefore there was a greater reduction than the actual size of the recession that year. If you ever want any proof that there is a coupling between economy and growth, it both goes up when the economy goes up and goes down when the economy goes down. We'd argue that this is a better way for us to understand the relationship between the size of the economy and emissions. So admittedly they've now gone down, but the gap is still quite big and significant between these emissions. So in essence, who is responsible for these? At the moment, of course, it's the UK. UK is not responsible for those emissions. If they occur in China, they are China's responsibility. We're not necessarily suggesting a complete reallocation of global emissions on this, but we're at least suggesting that countries should basically recognise that their responsibilities go beyond the territory of that country. If we were to adopt a potentially reduction targets based on consumption-based approaches, then this is a scale of reduction. It goes up from 67% to a 78% reduction by 2027. So anywhere between roughly a 70 to 80% reduction within 15, 16 years is the kind of target which we're talking about. So therefore we're talking at nearly a 10% reduction in UK emissions, not 2-3% a year. Now immediately I think this changes the way that we look at the climate mitigation problem. It isn't necessarily just about the development of future technologies, it's about dealing with the problem with the technologies that we have now. I think it's fair to say that we're not going to have a major breakthrough in a technology such as CCS till after 2027. If there are any CCS experts in here, feel free to discuss that and disagree with me. But we basically have to solve the problem with the technologies we've got now, and also then potentially face up to the level of consumption and the size of the economy that we have. So therefore I would argue that climate change is a short-term problem and not a long-term problem, or at least the mitigation is. The adaptation clearly is a long-term problem. Here's just a very simple scenario which would show potentially, well firstly here is our target where our emissions should be, and in this scenario we looked historically at the carbon intensity of production, or of consumption, sorry, in the UK, and 3.2% is the best improvement that we have ever made in 1 year on the carbon intensity of production, and that was a major shift in the electricity sector. We've never done better than that in 1 year. So considering we need 10% emission reduction a year, you immediately start to see the scale of the challenge. And this would be the gap in the available carbon space. So that's about an economic growth rate of about 1% a year, and then a carbon intensity improvement of about 3%. That would be how much we would be exceeding the carbon space within that time period up to 2050. However, if we were to meet those reductions up to 2027, you can clearly see, this is basically some simple maths here, the blue section becomes extremely small in comparison. And so therefore, if we are able to make short-term change and keep up with a sharp level of decline, even if we don't keep that up at a later level, we exceed the budget by an extremely smaller proportion. So therefore, I would say it's the next 10 to 15 years where we've got to understand how we would make radical changes and how we would deliver those scale of changes with known technologies and demand-side options. It doesn't take away any sort of need for long-term innovation in energy technologies and so on. Of course they're needed. We need negative emissions in the future. But it does put it into focus about what we need to do in the short term. What we have here is a structural decomposition analysis which we've done, which basically breaks down and gives us an idea about how these different variables would play out independently. So what we do in this analysis is we freeze each of these variables and then just run one of them and see what the emissions would be. So for example, with this green line, if the population stayed the same as 1996, if our final demand, the size of our economy was the same, if we consumed exactly the same mix of products and so on, then the emissions in the UK would have been nearly 250 million tonnes lower than they were. And so that's the carbon intensity improvements that we've made. If we look at the red line, we basically see that the structure of the economy has pretty much not changed or affected the emissions over that time period. We can say pretty much the same about the share of our products here, which is this light blue one. So I suppose you could categorise that as green products in a way. Are we greening the mix of household demand? And then finally, if everything else has stayed the same, then the emissions associated with final demand, so the size of the economy, basically would have gone up considerably further. So any improvements which we've made through consuming greener products, through carbon intensity improvements, have all been outpaced by an increase in final demand. I don't think we have a total detailed understanding of how those two interplay to be honest, yet, and whether one is dependent on the other. But in essence, the actual track of emissions is most greatly influenced by the size of the economy. So in essence, any growth in the future that looks anything like the past will in no way deliver anywhere near the reductions which we need. If we look at as well for emissions, but just look at it for energy demand in the UK, I think this is an extremely sorry story. Here is the territorial energy demand of the UK from 92 up to 2009, and that are the consumption energy demand. It's not quite flat, it's going up a bit, but you get the point that we haven't really been able to make a significant contribution to energy demand reduction. I always have an argument with Nick Eyre about this one from Oxford, because he thinks it is going down and I think it's going up, so we're going to try and write a paper on it and have a really good argument about it. But in reality, what we have seen is just relative decoupling of energy use from economic growth, and there has been nowhere near absolute decoupling. You could partly argue that, well, we haven't really tried, but whether we've tried or we haven't tried, the reality is that our energy demand, the size of our economy, while the economy goes up, our energy demand has at best stayed flat from a territorial perspective. Going on to materials and products for a second then, just to try and give the perspectives of emissions, energy and materials. If we just look at the first figure to start with, here is a global picture and then the UK over here. About a third of global emissions relate to industry, and industry is clearly there for the production of products for us to consume, of which about five of the high impact materials account for about half of those industry emissions. And here is another real problem we get when we're thinking about mitigation options. Here is an example of aluminium, but you'll get a similar picture for steel as well, and this is taken from Julian Allwood's book. And here is the improvements which we've seen in terms of the energy intensity of aluminium production. We haven't made much difference now over the last 30 years in terms of reducing the impact of production. We have some best case examples at marginally better, about 15% better. And here is our theoretical thermodynamic limit of how efficient you can produce that. And clearly we are running out of options. We have in lots of materials and quite optimized system. We don't have many energy efficiency options left. And finally we have the global demand here for these different materials. Now immediately it doesn't take a genius to work out that those emissions are not going to go down. They're simply going to go up. So somehow, when we don't have carbon intensity improvement options in some sectors, admittedly we do in others, we immediately start to run out of options and immediately should more and more be pointing towards the demand side. The other problem that we have is the emissions that are often going up are not occurring inside the UK, giving us even less influence over their carbon intensity. So in terms of our products, and products I use a broad definition which sort of accounts for our goods and services, over 50% of those emissions sit outside the UK, and that is growing. That was about 35% in 1990, and now it's 50%, and we're suggesting it could be up to 65% within the next 10 years. So we simply have less and less control over our own emissions. We also have these longer, more complex supply chains across countries, and why our kind of modelling can unpick those supply chains, we still work at a fairly aggregated level. And we're also seeing an enormous increase in the emissions associated with services. I think lots of people think that services could potentially be low impact, but in essence it's just shifting the product into intermediate demand and then we're buying the final product. So in reality what we're finding is an increase in all the materials which are occurring outside the UK, and we're getting less and less influence over these emissions. Just to show you sort of quickly how this might work, and here's an example, because we don't just run carbon through the model, we run water through it as well, thanks to a recent UCL project which we're currently undertaking. But on this side we have countries. These are the countries where This is the amount of water which we consume through our consumption in those particular countries, and here's the amount of water which we consume in total by products. And we've spent a lot of time basically creating the linkages between these. So this is a very large global trade model. We now have over 18 billion data points in the model, and this complex understanding of supply chains often tells us exactly if we change any of these product groups in terms of their level of consumption, we can therefore understand whether it be water, emissions, money. We can understand potentially the reduction that would happen. What we don't know so well is how this might act in a dynamic way, and that's part of the work which we'll be doing in the future, hopefully in the next phase of UKIRK, to try and understand in more depth what it means to change and how the world will respond to the changing levels of consumption. I've tried to sort of just finally switch the issue on the head of not asking how much are we exceeding the available carbon space, but ask how is the economy simply too big for the available carbon space? So just switch that question around. And so this one goes back to that scenario again where we're getting 3.2% efficiency gains each year in the economy. How much would we need to reduce the size of the economy each year to squeeze the UK into the available carbon space? And this is what it would be. So it could potentially by about 2027 mean that the economy would need to be about 35% smaller than it is to squeeze it into the available space. Now, there's a number of ways you can deal with this problem. I'm not necessarily advocating global recession, but we do need to recognise that the economy is oversized for the carbon space that we have. Also, a global recession is never planned. I'd like to feel that we can actually plan the future as opposed to just leave it to the whims of the global market. But in this respect, even with reasonable efficiency gains, the size of the economy would have to change. And so therefore, I know it's a slightly old age argument, but it's one worth repeating because it's one that we've never really taken on board. But clearly, just the measure of GDP is inherently flawed because we are not necessarily delivering even the social gains that we would hope, but at the same time we exceed the carbon space available. I'm writing just to try and get a reaction. We've written a paper which said this is how much we would need to have in carbon tax each year in the UK to bring it into size, and this is how big the carbon tax should be that we should introduce to it. But then we also have another problem, because if you were to introduce a carbon tax, I'll go back to that side. This is the one I wanted next. We clearly have a large distribution problem here. So what I did here was we worked out the complete carbon emissions of every item of consumption of different income groups in the UK. So these are 5% groups, hence there's 20 of them. So these are the 5% lowest income groups in the UK, and here's the highest 5%. What I really want is the data on those last 5%, because you can see the direction it's moving in, and I'm interested to know whether it will carry on that pattern of sort of almost exponential growth. But in reality, we can see that imagine trying to introduce a tax to try and bring this about, and a monetary adjustment to make all this happen. You clearly could have a rather significant effect on potentially the majority of the UK population, because in essence it is the people on high incomes that have the high carbon emissions. Now, so therefore their response to potential price changes would not potentially also lead to a reduction necessarily in their consumption at that point. So in essence, we'd have to be very careful if we're trying to make a rapid adjustment to try and protect the groups which potentially could be very vulnerable to carbon pricing. So this suggests to me that you've actually got to ban things. I can't think of another way of doing it without some really interventionist policies. And think about it in relation to cars. We've actually seen a fairly effective European policy on cars, which is driving down the emission standard quite quickly, and now they're beating or they're ahead of the standard in terms of carbon intensity that they should be. And that is not a price-driven mechanism. It is a mechanism which simply says that the average car efficiency must be this. They still obviously haven't been brave enough to say that you're allowed to drive a car of excessive emissions. You're still allowed to do that as long as someone else decides not to drive a car or drive a smaller one. But in reality, lots of the policies which I think can be most effective are ones which actually create a standard and even potentially think about the banning of most extreme carbon intensive materials. I fail to see how we can introduce an equitable price into this system, and it'd be interesting to get people's view on whether they feel that's a correct assumption, I suppose, in relation to, yeah, whether it's a correct assumption. We'll discuss that one after. So that's looking at the past, and we're just going to very briefly look at the future. Within our model, we've spent a lot of time now trying to understand what's happened in the past and how might this play out in the future for different sectors. We're developing some more dynamic econometric model at the moment, and we're using these approaches to try and understand the carbon intensity changes in key sectors in the future by different world regions, recognizing the kind of limits that they may have. We have this very detailed understanding of the past of the efficiency gains that we've made. So in our modelling, we partly rely heavily on what's happened in the past, but also try and be as informed as we can about what might happen in the future.
Better result.
Well, so, yes, it is. Yes, so they've got more carbon efficient, these products. Not much, some more than others. Yeah. And as well as understand the carbon intensity of production, then we've also, and this is the only way I can try and understand and explain how, we're also trying to understand where our final demand is going in the future. What products will we be using, which ones are going up and down, what's their relative scale. And we do this in a number of different ways. We both have projections of future growth patterns and so on. So we basically have in development, and we have tried it out to some extent, a model which begins to appreciate and understand how the interactions between price and might affect carbon intensity, and how this may affect final demand. We tried this out in a paper which we published in Global Environmental Change, where we started to try and understand, if we start to change the use of the products that we have, how could this contribute to climate mitigation policy? It was originally funded by RAP, the Waste Resources Action Programme. I think it's because they thought that they were going to have their budget acts. They wanted to try and demonstrate that they have wider relevance to society beyond waste. But in reality, I think they have a key point here, that climate policy generally ignores material efficiency and changing the way we use products. We looked at a range of different interventions with this style of modelling, from more production-led ones, lean production, that was more efficiency in the production of, and the supply chain of products, material savings along there. We looked at material substitution, changes in waste and so on. And then we also looked on the consumption side at a range of different options in terms of the way that we use materials and products. Lifetime optimization was to do with the fact that most of our products don't even reach technological obsolescence. We throw them away before they're no longer, while they're still useful. So for example, we attach to each different product category based on survey data when we throw them away and when they actually could be used for. Actually, we tried to do technological obsolescence, so planned obsolescence. But that's really tricky because no company will tell you how they've planned the obsolescence of their product. But of course they've planned the obsolescence of their product. It's got to be part of their business model. But in reality, we also then looked at shifts from goods to services. An example of that could relate to the use of car clubs over ownership. There was an incredible inefficiency at the consumption end. We almost optimized car production, and then we put a car onto the market which sits outside someone's house for 95% of its life, and then often has an average occupancy of about 30%. It's an incredibly inefficient way to use a product. So we looked at ways in which we would increase and maximize the efficiency and the use of products. We looked at the issue of reducing food waste, of dietary changes. This was a shift towards a more vegetarian diet. We looked at ways of increasing recycling, reuse markets, and we looked at ways in which public procurement could be significantly more efficient. And these scenarios showed that the other sort of most important thing about all these is we're not necessarily requiring a major technological breakthrough to achieve them, but I do recognise that we might need a potential shift in the way that society thinks about products and the way we use them. So in this example, we were able to get scenarios coming up to 50–60% in the reduction of products. Now, we've generally felt that products are ignored in climate policy, and so there's lots of additionality here. We also did another analysis, which I haven't shown here, which demonstrated did any of these emission reductions fall within the EU emissions trading scheme, and so therefore we couldn't claim additionality. But the majority of them occur in other countries. So therefore the immediate response when we presented this to interdepartmental groups was, well, they occur in China, why would I care about emission reduction in China? And it just reminds you constantly at losing the picture of what on earth we're trying to achieve and the consequences of that. We were then, following on from that, commissioned by the Committee on Climate Change, who were challenged by, well, there was a public inquiry by the Select Committee for Energy and Climate Change, where UCL-Energy Research Centre, led by myself, put in a evidence to that and then gave evidence to the panel, and that resulted in them telling the UK government that they had to monitor these emissions. DEC weren't particularly keen on that. They robustly refuted the fact that they needed to measure consumption-based emissions and they had no responsibility for them, but they got told they had to, so therefore DEFRA do them. It all makes sense. They also basically said that they expect the Committee on Climate Change to now do a review of what these options are. And one of the key arguments they immediately have is they create their own argument to knock it down, and that is, we're not changing the accounting system. But that isn't actually what was argued by many of the responses. What is argued is that if we look at something from a consumption-based perspective, it potentially opens up more mitigation options that we wouldn't have thought about from a territorial perspective. So it is about focusing on the problem and trying to address and come up with as many options as possible. So this is one of the two 4-degree and 2-degree scenarios which we did for them. And so this involved projecting all the regions of the world into potential carbon intensity improvements in the model. This is what would happen to our territorial emissions here, and they are suggesting that we would have a 2-degree future if our emissions from imports, which is the green one here, so this is the 2-degree scenario, would reduce to this amount. So it would no longer be even an 80% reduction. They don't think that's possible because they don't think the rest of the world can move quick enough in terms of carbon intensity improvements. And of course there's no scenario which potentially would question the size of the economy. And here is the 4-degree one. As you can see, it's a very modest reduction in emissions in the UK. So what are we talking, 50% maybe over the next, whatever that is, 30-something, 35, 36-year period. After they developed these scenarios, their main conclusions were that, well, the biggest conclusion was we have to keep an eye on these. So that was the main finding of the report. But they did also show that there wasn't really major competitive issues if we were introducing a price. And I was thinking, well, of course there aren't major competitive issues. We barely put a price on anything, so how could there be? But in essence, they came to the conclusion that we shouldn't listen to industrial lobbyists when we're trying to hand out free allowances. And then the final conclusion was that we should start identifying policies which might have perverse impacts. And I thought this is a slightly more interesting one because if we were, let's say, to push for a biomass policy which related very highly on imports, there is the chance that we could be creating greater emissions elsewhere in the world. So our territorial emissions are going down, but our overall contribution to global emissions goes up. So it's to start identifying those sort of perverse policies which drive global emissions at a greater rate than our territorial emissions reduce. To try and address lots of these problems, we recently got funded an end-use energy demand centre from the research councils, mainly through their energy programme called UK in Demand. And it started 4 or 5 months ago. But under this, we're working with Cambridge, Julian Allwood at Cambridge, Jeff Hammond at Bath, and Tim Cooper at Nottingham Trent. We're basically trying to understand whether, if we look at these global supply chains and understand products and materials in considerably more detail, can we start to identify further mitigation options which potentially wouldn't occur under more classic, I suppose, forms of modelling. We're very much trying to understand what it means to change at scale. I'm sort of feeling there might be a bit too much work on understanding incremental changes and not enough on understanding what it means to make quite a strong, I suppose, radical intervention in terms of emissions. And then the other work which we're sort of working on and trying to do in the future is to really explain these pathways, because even if we feel that our research is being ignored by the people we'd like to, I think we constantly have a job to be able to paint what that alternative pathway might look like, to try and make it as attractive as we possibly can. So in essence, we're doing a lot of work on understanding what's the role of governance and institutions in potentially low carbon futures, what might be the role in changing attitudes and behaviours, how might the economy look like, what kind of jobs might we have, what will happen in terms of investment. And we're trying to provide this detailed picture basically for products and how we use products differently, feeling that that is one of the areas partly excluded, as I've mentioned. And then of course outline exactly what these policies and strategies are to deliver. I've just got to give some practical examples here. I put this up here as our sign of progress, you see, about the fact that we constantly lose the benefits of increased efficiency. And the problem is that this isn't really, that they have pretty much the same efficiency. And that's our sign of progress over time. I'm guessing you noticed a different size, you know, just to be clear. I don't know how clear that is at the back of the room. But in reality then, it's about understanding how we deliver these services differently. And lots of the work really goes into understanding more what a circular economy, the redesign of products could mean, the shifts to services and the new business models that exist under this. We have 5 years to do this, but clearly we want to deliver quicker than that, as we've already sort of made a decent head start. In terms of the major modelling side of this, this really is a major expansion of us combining our economic model and integrating materials and energy more effectively within that model. In essence, we have an incredibly detailed production structure of economies, but we don't link with that. We don't link energy systems models to that so clearly. We don't link potential models which give us more dynamic forecasting element to it. So that really is where we're moving. I think most of the exciting areas are in combining different modelling approaches to try and answer a really sophisticated, complex question. And just to give you an idea about how we might go about doing this, Julian Allwood has very detailed pictures of how materials flow through economies. We have very detailed ideas about how economics and money flow through economies. And we want to make sure that we're not just using money as a proxy for material flows. If we don't sort of separate that link, then we have the problem that we always believe that a reduction in either the economy would mean a reduction in materials, or the other problem where we get a reduction in materials and we believe the economy comes down, which may not necessarily be the case. So it is about building a modelling framework to answer this extremely complex problem and paint an alternative picture, I suppose, of the future in terms of the products that we consume and the way that we live. So I'm going to stop there. Thank you.
go right back to the beginning and look at your first slide?
Yeah, okay, yeah, sure.
I want to question your assumptions.
Oh, yeah, sure, no problem at all.
And exactly how you get to this 97%.
Yeah,
you
sure.
Multiply the units by 4 to get back to gigatons CO2, because I think it's useful to stick everything in the same units. Yeah?
Yeah, they are in the same units on this slide, aren't they? These two.
On this slide they are, but you go into CO2 on other slides. So
oh, right, okay, yes, fair enough.
Stick with tons of CO2. You talk about conversions and contraction, are you?
No, the way, I'll tell you, the way it's done is for a 2-degree future, they're defining a certain carbon budget associated with that, because of course emissions are cumulative. So therefore there is defined carbon budgets which are likely to lead to avoiding a 2-degree increase. I can't remember exactly what that budget is now. I know that Menshausen came up with a budget which is published in Nature, and that was updated in the IPCC report.
Right, but
you take that carbon...
per capita basis.
That's what I'm going to say. Yeah, that's my next line. We take that carbon budget and divide it by current global population. Now, I'm not saying that's right or wrong. It's an experiment, because you could almost argue that you could take an average projected future one as well, potentially. But in this particular example, we took that budget, divided by current global per capita basis, and allocated it to countries based on that from now and into the future. And then with the 67% probability, that gives a 97% reduction.
So you're allocating the same per capita emissions for every person on the planet? Yeah,
yeah, so basically you have the same right now to emissions that anyone else in the world would. That's the assumption.
And you get a 97% reduction?
Yes, you do, yeah.
Okay.
Yeah.
Well, I'm astonished. I still don't understand where that comes from.
Well, you divide the... yeah, that's what you get. I'll send you the figures if you like. Yeah.
Yeah, so related to these figures, the International Energy Agency, their annual outlook this year, they projected ahead, I don't know the details of where they got to it, but projected ahead that they think by 2035, or around that period, historic emissions from developing nations will be equal and then beyond OECD countries.
Yeah, sure, I've seen similar to that, yeah.
There's also the consideration that obviously we emitted a hell of a lot in the past of the Industrial Revolution, but the technology available to developing nations now is an awful lot better than we had then. So with the combination of those two things maybe affects whether we're looking at a 97% reduction. Because in reality, I don't think our democratic system is ever going to say yes, we'll sign up for that. Definitely.
No, I agree. This is more as a thought experiment to sit there and say, do we have a greater right over emissions now than anyone else globally? I think it's difficult to argue that we do, but that's more an allocation of responsibility as opposed to saying what the solution might be. Clearly, the solution must rely on developing countries moving rapidly to low carbon technologies. I'm not denying that. It's about who takes responsibility and who pays for that, I think, as well.
I guess the point from the IEA was that by 2035 there would be a broad sort of level of equality of historic emissions that would broadly we'd have emitted the same historically.
But not on a but not on a per capita basis. It wouldn't be. It definitely wouldn't be on a per capita basis.
No, perhaps not on a per capita.
Yeah, but it would be as an absolute basis. So it depends, I suppose. Yeah, I suppose I'm not going to I wouldn't totally defend a 97% reduction, but I think what I would say is that I think we've stopped looking at the assumptions of what an 80% reduction really means, and we should have a more honest and transparent discussion about what that means, as opposed to blindly adopting a target which has what I think are some questionable assumptions behind it. So, and also whether it's 90% or 97% by that time period, it's a change which is significant, and it's also a change because of the way that cumulative emission, because emissions are cumulative, that means that those emission reductions happen to happen in the short term and not between 2040 and 2050. Hence, an endpoint target is quite is pretty nonsensical.
In relation to resource efficiency and decoupling growth from the environmental impacts, at a recent conference last week, which was the final conference for a European project looking at resource efficiency. It's called Resource Efficient. Towards a resource efficient
yes.
project. Right?
Yes, I remember. Yes, I know. Yeah, I was invited to it. Yeah.
One of the interesting things that happened at that conference was that a rep from Friends of the Earth made the point that one of the most progressive companies which have managed to move towards resource efficiency in reducing its water impact, its waste production, and its emissions was Unilever. And what they said was that Unilever had managed to show they basically halved their environmental impacts over the particular period in question, but over the same period, Unilever's policy was to double growth.
Yeah, sure.
So the net result was zero.
Yeah.
And that was the most progressive company we heard about. The rest of the conference was notable because one guy from the aluminium industry, and another from mining, both from kind of European federations, spent the entire conference challenging just about everything and basically saying we see no reason why we should be curtailed and we don't accept any of your maths or any of your indicators.
I think it's a great point. Yeah.
Modelling is fantastic, but when it gets down to making change, industry and government, this is the point being made, seems quite happy with some very optimistic growth projections because politicians don't like scaling down growth projections. Do you have a sort of...
I completely agree, because often you find firstly that industries report their carbon intensity and not their absolute emissions. And the trouble with isolating an individual industry and trying to see what it's done is that you require systemic change, but you're trying to understand the problem with individual examples, and they don't match. So I completely agree. How you stop governments being obsessed with a growth agenda, if only I knew. If anyone else wants to answer that question, I'd be really grateful, because I don't think I necessarily know the answer. But I would like to feel that as academics we have a responsibility to at least paint as detailed picture of a future that we possibly can, to recognise that certain I suppose societally beneficial outcomes can be consistent with doing things completely differently, and at least being honest and highlighting where they're not consistent when we're doing them differently. Like, what does it look like in terms of where do we work and how much do people work in an alternative picture? And I still don't think we've gone far enough to really understand that. Now, I know it's very difficult because there's an incredible amount of uncertainty in that future. But my feeling is that we can be as prepared as we can for when, hopefully, at some point the agenda does and potentially will shift. But in terms of creating the momentum to do that, I find it very difficult. I went recently and presented at the Radical Climate Change Conference, which in the Royal Society, which Kevin Anderson and others organised. And again, there were lots of sort of political scientists there and other sort of thinkers. And I was still waiting at the end for someone to tell me how on earth we make people look at the world differently to create that kind of shift. And I still haven't really found an answer to creating that momentum. And I suppose I think it's one of the biggest problems that we face. And someone else is going to answer it now.
You've assumed there's no technical breakthroughs in materials, for example?
No, a certain level, yes. So we assume that it depends which sector. So, for example, in the steel sector, in our future projections, we highlighted that we could only see up to about 25% further improvement. And in other sectors, of course, there's scope for more. But we're saying that most of the easy options have been taken.
Would you say that the two primary candidates are the creation in a continuous production process of crude oil from algae, which we last year, and the second one is the the beautifully symmetric production of carbon-60 from the atmosphere, CO2 or methane.
And when can we roll these out at large scale, do you think?
Well, the crude oil, you can make it in about an hour in your kitchen.
No, but I mean, when will it happen?
Well, have you studied the?
No, I don't know those particular. I don't know those particular potential solutions.
Well, I mean, is that a good route to look at? Is changing, because you talk about banning something. If you can ban fossil crude and only
I agree.
Neutral crude, I mean, that surely is the quickest.
Sure. Yeah. I should say that when I present this, I suppose I'm not. It's not an anti-technology perspective, and part of that banning one, I was always really taken by a book by Wolfgang Sachs, who always highlighted that and until you foreclose options, you don't drive the innovation, and that's a good example, I think, because until you say that you're not allowed to actually take any more oil out of the ground, I think we're going to see very slow development of alternatives, whereas if you actually start to ban options, then you start to see innovation in driving it forward and those kind of options coming forward. But I don't know the particular innovations myself to be able to say when they'd be ready for market and how effective they could be. But of course, I'm open. I wouldn't discriminate against options. Not there.
Sounds ideal for an energy system model to
yes. Oh, we could. Yeah.
Paul.
I've got background in manufacturing industry, transport industry.
In what? Sorry,
Innovation.
Sorry, I missed which industry sector. Sorry, I missed the industry sector. You said, did you? I missed what you said. Sorry, I couldn't hear.
I've got a background
Yeah.
in manufacturing industry.
Oh, thank you.
And in the house building.
Oh, okay.
And also in innovation. So the first comment I would like to make is that in terms of what you're doing, as you've discussed at the Royal Society, the way you actually influence politics is people. And the biggest problem in the UK and many other nations at the moment is that people do not perceive that there's an issue and they do not perceive the need for action. And your answer as to why politicians won't act is very simple. The electorate will kick out of the kind of taxation we're talking about. So we're talking about people, which brings me to your demand side comment. The other side of your graph there from industry was the built environment. And what we've seen in the recent work I've been involved in other work that's gone on Leeds Met quite a lot as well, is that it's again people. You can do what you like with the product, with a modern office, with a modern home, but there is a 200 to 300% difference in demand side energy use between identical homes per capita and identical occupants. We've got big social issues here, and we tend to be very techie. Techie's easy, believe me. I'm a techie. It's easy. So, to me, you're outlining the playing ground, and I think the challenge is social.
I think it's a really valid point. Yes. Yeah. I don't know if I agree.
Yes, thanks, John. Challenging presentation as usual. I'm going to rise to the challenge first of all about the carbon price.
Okay.
I said I don't see how we can do that because I'm into carbon pricing.
Yes.
You know. It's very easy to see, and we showed it with some work we did at the Joseph Rantry Foundation with IFS, Centre for Sustainable Energy, that if you look at increasing the price of energy, we did it through increasing VAT on household fuel, which is the largest environmentally perverse subsidy this country has.
Yeah.
And it's very easy to see that the low-income households benefit relatively little from that subsidy. High-income households benefit much more because they consume more energy. And were you to remove that household subsidy, government would get a lot of revenue, which, were it so mindful, it could use to make society much more equal it could use it to reduce the fuel bills of low-income households, and it could use it to make low-income households much more energy efficient, so that they needed less energy to keep warm. All that is perfectly clear. When I presented the evidence to the Environmental Audit Committee, one of the members came up to me afterwards and said, of course that's right, but it's political suicide. And indeed we know it's political suicide because the Conservatives tried to implement it in the 1990s. Now they didn't do any of the redistributional stuff, which brings me to kind of my broader point, which I guess is the challenging point, which is a point I make to Kevin, my good friend Kevin Anderson as well, which is that I think as policy academics, the question that we have to try to answer is, what policies do we advocate that are likely to bring about the most carbon emission reduction, if carbon emission reduction is our goal. And in order to bring about carbon emission reduction, they have to be implemented, because policies that are advocated which are not implemented don't bring about any carbon emission reduction at all. And therefore, in our calculations of what policies we propose, we have to take into account political feasibility. Now, political feasibility is a very, very fungible thing, and it changes over time. And we have to try to judge what is politically feasible now. And I think it's very valuable to have this underlying analysis that you've put here to show the extent of the problem. But every time I hear a presentation like yours, I want to go and lie on the beach, because I know that there is nothing that can come anywhere near those graphs which would be remotely politically feasible. Nothing that I suggest, and the policies I put forward, are much less radical than you would need to do that. No one takes any notice of those either. You know, and I'm frequently accused of being politically unrealistic, but I'm aiming at targets like the 80% target, which are much easier to meet. And I just think this issue of political feasibility is one that we can't ignore as policy engaged academics. And it means that we know we're going to be putting forward policies that won't hit those kinds of curves, but they might reduce emissions by being implemented, whereas the other kinds of policies might not be implemented at all, in which case they won't reduce emissions at all. So just give reflections on it.
I'm probably going to give an answer similar to what Kevin gives, I suppose, but I'm not just a clone of Kevin Anderson. So there's a few things. Yes, of course, but one thing that I'd like to at least feel that we can be a bit more honest about the whole issue, and then recognise that even 2 degrees is simply not a possibility. So I think we should stop kidding ourselves to start with. And so I don't see why we shouldn't be approaching this with an element of realism. But I also agree that that needs to meet an element of practical approach at the same time. And in some defence, I think the in-demand centre will come up with those practical solutions. So it is working with the construction sector because it recognises that new buildings are twice as heavy as they need to be to meet building regulations and standards. And there's key reasons why that's the case. We do recognise how business models need to change. So we are working at that level. So I'm not sure if they're mutually exclusive either. And I'm not sure why we can't be realistic about the scale of the problem, but also be working on these practical solutions, because I think I have worked on practical solutions. So my feeling is that we can do both, and I'm not sure. I don't see this as an either or in that respect.
If I can just come back, I mean, the practical solutions that one would be working on, if they are practical, are not going to get anywhere near that yet.
Well, we might as well forget. Well, maybe we know we need to forget 2 degrees then.
And you know, ever since Machiavelli, people have known that practical politics very often does not involve honesty. And I'm not saying that in favour of dishonesty, but that it may be that if people were to realise the scale of the problem, and there's a lot of psychological analysis about it, they would simply say, well, it's hopeless, we're not going to do anything at all. And then we wouldn't be heading not for 2 degrees, we'd be heading for 6 or 8 degrees. Whereas if we're more pragmatic, we might get to 4 degrees. And actually, there's rather a lot of difference between 4 degrees and 6 degrees and 8 degrees. So I accept what you say, obviously.
Yeah,
I mean,
sure.
these are tough issues to which there is no definitive answer. But just, it was a nice answer.
No, okay.
Okay, we're rapidly running out of time, so I'll take two questions. So one.
Tony Edwards, architect. About political feasibility you talked about. I mean, you've already said a lot of it, of what I'm saying. Politicians notoriously have very short horizon of time to make policies, and they don't like to stick their neck out beyond their voters' prejudices. So where comes the role of coming from the other end, the grassroots? I mean, there was a talk, I think it was Energy Institute, I can't remember, it was Mike Berners-Lee and Duncan Grant about their book, The Burning Question.
Yes, yeah.
And they had a final concluding chapter saying everybody who knows these figures and knows it's important should always, in every meeting, every business meeting, or every church meeting, or every social occasion, must simply gradually get the ball rolling. How do you see, I mean, taking this grassroots, in this borough of Camden where we are now, 5 years ago there was one transition group, I think. Now there's about 18, you know, transition Hampstead, transition Belsize Park, transition Primrose Hill. They're spreading all over quite posh as well as quite moderate budget areas, and they basically, it's a social movement. There may be quite a lot of people who are not very knowledgeable about climate change at all, but they rather like the general social meeting and getting together, and this can get the ball rolling. I mean, you don't have everybody needing to be an academic climate change expert.
No, I agree.
To tell the politicians we're not going to vote for you if you don't do this. I mean, where do you see grassroots coming as against the top-down legislation and industrial choices? Sure.
Well, I've been involved in grassroots sort of activities myself for many years, and I've always found it very challenging, if I'm going to be really honest, and partly because I always felt that it seemed to be the same group of people all the time, and this is more of my anecdotal personal perspective, I suppose, but I always felt that there was this sort of group of like-minded people who talk to like-minded people, and of course they can grow organically as you've described, but to me they seem to have the same sort of, where we have this sort of time lag in terms of technology development, we seem to have the same kind of time lag in terms of social change and the growth in social movements to make that happen. And I suppose it's got to be everything at the same time, because I can't see any of these moving at the right speed, but hopefully one in essence helps enable the other. And if, as related to the question and the comment before about it's people and the societal problem, then surely there has to be that change. But that change then has to also then be recognised on a political level, because that's where, to me, the scale of change needs to happen, and that's where we could only make it happen. So I would hope that one would facilitate the other, but my major concern is just the speed of it, and it's just as slow as new technology is rolling out. It's more of a personal reflection, but yeah.
About change, and I was very taken with the notion that it's people that drive change. Politicians only do what people do, but I think the fundamental problem that we need to address, rather than the technical modelling, is the people's time discounting of, if this is sufficiently far ahead that it's not going to affect me tomorrow or in the lifetime, then that's the problem, is that you can ignore it. And we've successfully attacked that with smoking, so there are now 20% fewer people who are, people are smoking or less. It's just, how do we get that argument over such that the politicians who we vote in actually come in with a mandate to do those drastic changes? Now that isn't going to be changed. It's going to be changed by a combination of things such as your very eloquent exposition of how materials supply chains work and how systems models and how energy models work. But I think there's a piece of work, there's a missing piece in the jigsaw here, which is how do we engage with psychologists and industrial psychologists and the like, nudge theorists, all that, to actually make the connecting things fine. So if we don't do this, my granddaughter won't be living anymore. She'll be consigned to the same place that the dinosaurs are. Do we really want that?
No, sure. I
get that. I mean,
yeah.
That's just looking at a different place. And the question was before all this stuff was, what if you were going to have to introduce one thing you wanted to stop? You had a little magic wand. You said, what technology was it that was going to give you the biggest bang for your life? You talk about stopping things, as it were.
Which technology would I pick?
What would you pick? I mean, if you were tomorrow, you were dictator of the world, and you said,
"All right, wow."
You can't do anything. You're going to stop off driving cars, or I don't know, burn coal fires, or whatever. What sort of people we're talking about?
No, okay. Well, you see, I don't have a strong opinion on the activity. Well, I'll get there. I'll get there. Yeah. I don't have a strong opinion on which. I don't actually care which technology wins, to be honest. I don't care if it's thousands of wind turbines or PVs on every house. The target is emission reduction, and if my argument goes that I'm finding it very difficult to understand how this could be achieved with GDP, my one change might be just to start to change how we actually measure progress, so that GDP is completely gone, and that my one change would be that instead of the BBC reporting that GDP has gone up by 0.1% or down by 0.1%, interestingly, when they said it went down by 0.1%, ONS adjusted the figures 3 months later and it actually went up by 0.1, and that was days of news. Would be that we'd had the same emphasis on key societal goals such as social mobility, health and so on, and that those became the foundation of monitoring success. And then I think everything else would follow that, and whichever technology wins through then, I don't mind.
He said that when he came to power, and he wanted to measure the nation's happiness, and that is after the goal.
Yes.
Kind of big, he mentioned that for something.
No, he hasn't now. But is it okay if I don't have a technological change then, and I have a progress?
Well, a magic wand.
Okay, there we go. That was my magic wand. Thank you.
Please join us next door for the drinks and